What's up, guys? I've had a ton of questions about this dyno, so I'm just going to take a minute and walk you through it. All right, so here it is. We've got a basic frame just built. It's 3x4 square tubing, really thick wall. I don't remember exactly what thickness. Way overkill for this project. I've got it sitting down here on these industrial casters, which are super nice. You can see you can just turn a knob there, and it pushes down a rubber foot. So you can basically make this thing rubber mounted just by turning a couple knobs. I use that on a lot of my big equipment to make it maneuverable around the shop. So out here we just got some bracketry for the exhaust. There'll be a little bit more for the water box over here eventually. Got motor mounts bolted on here. I did raise them up a bit just because I wanted to be able to get the flywheel cover on and off easier. I got my other 1200 sitting here, just mocked up. Some water lines here mocked up. But moving backwards, there will be a 5-finger coupler here on the engine, of course, connected to the coupler that connects to this water brake. So what we have here is a 13-inch land and sea water brake. That's what this basically is it's very similar to a torque converter on a car. Okay, you pump fluid into it, and it creates friction and applies a load to the engine. So you pump water in back here in this big inlet, and based on the amount of water you're pumping in, you change the amount of load on the engine. So there's basically a wheel that spins inside of that. It's attached to this shaft, and it just creates a brake against the engine. So that attached to that is a piece of aluminum here that is attached to an S-type load cell. And this is actually how you measure load on the engine. And this is mounted exactly at 1 foot from center. So you're measuring basically foot-pounds of torque. And then of course you can convert that to horsepower based on RPM. So on the water brake, of course, you're pumping water in here at a pretty high volume. You've got an outlet here, 2 outlets I should say, and they'll just go back to the large water tank that I have for this. So in order to control load on the engine, you need to be able to control how much water is going in here. And we do that with this valve here. So the other day I posted a video up on Instagram. I designed and 3D printed this bracket here, which allows me to adapt a NEMA 17 stepper motor to this land and sea water valve, which was originally manually controlled. There would have been a knob on top here. So a nice adaptation there. We'll see how well it works once we get this thing running. Water will of course come in here. I haven't hooked that up yet. And I'll have a T here to run water to this splitter, which is just a garden hose splitter, which will run water to the engine itself for cooling. Maybe eventually we'll do some sort of RPM based water valve system there, but that'll come later. So moving back, we've just got this 3D printed box I quickly designed and printed to mount the YourDyno digital or data acquisition system. That's what controls the dyno and does the data logging and stuff like that. We'll also have a stepper motor driver here, and yeah, there's a weather sensor or a temperature and humidity sensor that'll bolt on out there as well. So that's pretty much the brains of the dyno. There's not much to it really. All you're really measuring is load with this as a factor of RPM. Now there's other inputs we can put into this controller, such as wideband O2 or something like that. But to start out, we're just really looking to measure power and make changes to the engine and changes to the components surrounding the engine and see what it does. First thing we're probably going to bolt on is that JSN 1200. Really the first one built with production cases and things like that. Bolt it on here and see how it does. This is an original TPE 1200 that I've modified a little bit, but we'll put it back to basically TPE specs and see how it compares. And we have other motors we're putting on here. I've got a PHP here, 1015, which we'll probably slap on there at some point. And 964s, 1105s, you name it, we're going to put it on here and see what they do and see if we can get more power out of everything. So if you have any questions, drop it in the comments, and yeah, thanks for watching.